Hello everyone. In this video, I'm going to discuss about stacks using linked list in data structures. So in this, I'm going to discuss what is meant by a stack and different abstract data types like push, pop, display, peek, isEmpty, and isFull. So in the previous video, I already discussed about stacks using arrays. So please watch it before watching this video. Now let us see the definition of the stack. A stack is a collection of elements where we can insert and delete the elements in the same direction. That means insertion and the deletion of elements are allowed from one direction, that is from the top of the stack. So here insertion is nothing but pushing the elements into the stack, and similarly deletion is nothing but popping out the elements from the stack. So in this stacks, we will consider a variable called top. This top is always assigned to the starting node in the stack. So as we are implementing stacks using linked list, so there will be a particular node. So in that node, there will be two fields. One is data field and second one is the address field. So the data field acts as an input variable. It can be of any format like integer, string, character, etc. So the second field is the address field. It stores the address of its previous node. So for the first node, the address field is always null. So whenever the stack is full and the user still wants to push the elements, so then the stacks get overflowed. So whenever the stack is empty and the user still wants to pop the elements, then the stacks get underflowed. So the stack is implemented based on LIFO method, which means last in, first out. So this is the brief introduction about the stacks. Now let us look at the abstract data types that are used in the stacks. So there are total 6 abstract data types. The first one is push. Here push is nothing. Push function is nothing but it adds a new node containing the element to the top of the stack. So whenever we perform a push function, a node is created with two fields. First one is data field and second one is the address field. So based on that, the top variable is assigned to the particular node and the address field is also assigned to the particular node. The second data type is pop. It removes and returns the top node from the stack. So the third one is display. So it shows all the elements currently present in the stack, usually from top element to the bottom element. The peek function, it returns the top element from the stack without removing it. So isEmpty function, it checks whether the stack is empty or not. It returns true or false based on that. So similarly, isFull, it checks whether the stack is full or not. Based on that, it will return true or false. So as we are implementing stack using linked list, the stack is considered full only when no more memory is available to create a new node. So under normal conditions, it returns false until the memory is exhausted. So these are the abstract data types. Now let us understand clearly with some examples. So initially we will have a variable called top. It is assigned to the null value. So if you want to push an element 10 into the stack, then we will create a node. We will scan the input variable, and the for the first iteration, the address will always be null. So for the second time, we want to push an element 20 into the stack. So a new node is created. We will scan the 20, and then the address of 20 is connected to its previous node, that is 10. Similarly, if you want to insert, if you want to push an element 30 into the stack, a new node is created. We will scan the input element, that is 30, and the address of 30 is linked with this previous node, that is 20. Similarly, now if you want to pop an element, so now if you want to pop an element, then we will remove 30 and the top element is assigned to 20. Again, if you want to remove the, if you want to pop out the element, then we will pop out 20 and then top element is assigned to 10. So here now peak value is 10. So this is the explanation of stacks using linked list. Now let us write a C program of understanding the stacks using linked list. So this is the C program for the stacks using linked list. So the structure format consists of two fields. First one is data field and second one is the address field. So initially I declare a pointer variable called top. It is null initially. So in the main function, I just declared the functions which are push, pop, display, peek, isEmpty and isFull. So coming to the push function, it consists of one input parameter which is a ELM. So initially we create an empty node. This node consists of two fields. One is data field and second one is the address field. So first temp of data is equal to ELM. So if top is equal to null, so for the first time the top is always be null. So if top is equal to null, then top is equal to temp and top of link is equal to null. If not, temp of link is equal to top and top is equal to temp. So coming to the pop function, the temp is assigned to the top node. The top gets moved such that temp is temp of link, and then we will free the temp and then return the value. Similarly, in the display function, we will assign the temporary variable to the top element. We will print the temporary variable until we reach to the last node. So in the peek function, we will return the top of data. So in the isEmpty function, if top is equal to null, we will return true. If not, we will return false. Similarly, in the isFull function, we will create an empty node and store it in the temporary variable. So if the memory is full, then the temporary variable address will be null. So if temporary variable address is null, it will return true. And then we will free the temporary variable and then return false. So this is the C program for the stacks using linked list. So thank you for watching this video till the end. Please like, share and subscribe to the channel. If you have any doubts or feedback, please comment below. Thank you for watching.